Okay, ladies and gentlemen, this is the second video to wrap up our little second review for this test. Okay, so solve this problem below algebraically. I want to get everything on this side. So I get negative x to the fifth plus 5x to the third plus 50x equals 0. We always want our leading coefficient to be positive, so I'm going to divide everything by negative 1 right now. Okay. Then, do I have a GCF? I do. It's an x. Okay. And now this becomes just a normal, like, hey, here's negative 50 on top, here's negative 5 down low, negative 10 and 5, cool. So x squared minus 10, x squared plus 5 equals 0. Set each of these equal to 0. Okay. X squared equals 10, x equals plus or minus root 10, x squared equals negative 5, x equals plus or minus root 5, and then x equals 0. Okay, so a fair amount going on there. Again, the more work you show me, the better off you're going to be, but once you have a trinomial like this, you're set to go. Okay, over here, get everything equal to 0. I believe this is the harder one we talked about yesterday in class. Factor by grouping, because there was no GCF, I could take out an x cubed, and I'm left with x minus 5. Over here I take out negative 8, and I have x minus 5. So the x minus 5 goes out front, and I'm left with x cubed minus 8 right there. Okay, now, bear with me. This is a difference of cubes, which is this. A cubed minus b cubed, which is a minus b, a squared plus ab plus b squared. Again, that's on your board, so we're going to use that. So this stays x minus 5. This becomes x minus 2 because a and b, a is x, b is 2, cubed root of 8 is 2. I'm using this right here, x squared plus 2x plus 4. I'll plug everything in there. Alright, these two are easy. X minus 5 equals 0, x equals 5. X minus 2 equals 0, x equals 2. This I can't factor, so we have to use good old Pythagorean theorem. It's no big deal. You just have to plug things in. So I've got x equals ABC, negative 2 plus or minus 2 squared minus 4 times 1 times 4 divided by 2 times 1. Negative 2 plus or minus 2 squared is 4, minus 16 is negative 12. Plus or minus, that becomes 2 root 3I over 2. And then everything's divisible by 2. Negative 1 plus or minus root 3I. Okay? So there's our answers. So we only use quadratic formula whenever you cannot factor it, which is a pain, I know, but it's not that bad. Again, that'll be on the board for you. Okay. Number 10, much the same here. Get everything equal to 0. Okay. GCF. Well, there's an x common in all of them, so I'll pull out an x. Oops, sorry, that's just a regular x. And then minus 24. Okay, so now factor by grouping. I could take out another x cubed here. I'm left with x plus 3. Take out negative 8 here. I'm left with x plus 3. X plus 3, x cubed minus 8. This looks eerily familiar. Hey, check this out. Guys, if you do happen to run into this, I don't know off the top of my head, but if you do, please don't go through all the trouble of doing all this again. You already did all the work up here. So when I factor this, I'm literally just looking up here and copying this down. And the reason I'm doing that is because it's exactly the same. Alright, so now I set x equals 0, I win there. X plus 3 equals 0. X equals negative 3. X minus 2 equals 0. X equals 2. And as far as this goes, I don't want to do more work. I'm just going to copy down the answer that I got up here. X equals negative 1 plus or minus root 3i. Okay? I mean, obviously, if it's a different problem, do it, but I think you're only going to get like one of those anyway, so you're good. Okay, number 11. This is a difference of squares, for the most part. So I got negative 36 up top, 0 down low. What numbers multiply give me negative 36 after 0? 6 and negative 6. So I go x squared plus 6, x squared minus 6. So each of these I'm going to say equal to 0, since I'm solving for it. X squared plus 6 equals 0, x squared minus 6 equals 0, x squared equals negative 6, square root it, x equals plus or minus root 6i. Over here, x squared equals 6, x equals plus or minus root 6. You're good? Okay. Cool. Alright. This is the grand doozy of them all. This is that more difficult problem I was talking about. I'm going to set this problem up and briefly talk about it. And I want you guys to try and play around with it, and we'll go over it in class a little bit. So, here we go. A painter is preparing a room for a new paint job. The height of the room is 2 feet less than the width, and the length of the room exceeds the width of the room by 7 feet. Okay, let me draw a picture out. If you draw a picture, this is not a bad problem, but nobody likes to draw pictures. Here's your length, here's your width, here's your height. Okay? I mean, simple enough. Look around the room right now, you can see this. The height of the room is 2 feet less than the width. I'm going to call the width x. The height is 2 feet less, x minus 2. Sorry, there's that box in the way. And then it says the length of the room exceeds the width of the room by 7 feet, x plus 7. I genuinely think every single one of you can do that. I'm hoping every one of you can do that. Just all you gotta do is read directions. Okay, if it says less than, it's minus. Exceeds is plus. Okay, the tricky part's right here. The area of the 4 walls exceeds the sum of the areas of the floor to ceiling by 164 feet. All right, now please bear with me. What is this wall's area? It is length times height. Okay, because there's a height right here, right? How many of these walls do I have? 2 of them, one in the front, one in the back. So I have 2 times LH. Then it says the area of the 4 walls. So I also have this wall. Well, this wall's area is W times H. How many of these do I have? 2. Okay. So it says the area of the 4 walls exceeds the sum of the area of the floor. So this is bigger than. So over here I'm going to go ahead and put an extra 164 feet. It says the sum of the areas of the floor to ceiling. Well, what's the area of the floor and the ceiling? It's just length times width. Okay? And how many of those do I have? 1, 2. Okay. That's the most difficult part. Now, the next part everyone's going to freak out about, but what's your L? Your L is x plus 7. What's your H? X minus 2. I'm taking all of this and plugging it in over here. If you can get to here, you're getting 2 out of 5 points for the most part. Okay? So now I'm plugging everything in. X plus 7. Height is x minus 7, or x minus 2. Plus 2, my W is x. H is x minus 2. Length is x plus 7. Width is x. Okay, a lot of foiling, a lot of cleaning things up. First part, if I FOIL this out, x squared plus 5x minus 14, plus here, distribute, 2x squared minus 4x. This is a 2x right here. Okay. Alright, I'm going to go ahead and multiply the 2 across. Okay. Alright, now, there's an equal sign right here. What you do to one side, do the other side. So I can cross off the 2x squares because they cancel out. I'm going to move everything into this side. So I have a 2x squared chilling out front. If I subtract the 14x over, let's see here, I got 10x minus 4x is 6x minus 14x is minus 8x. And then negative 28 minus 164 negative 192 equals 0. Okay? Do you see a GCF here? Yes. 2, I can divide everything by 2. I get x squared minus 4x minus 96 equals 0. Now, let's see here. 4 and 24 doesn't work. 12 and 8 works. I can factor this. So what numbers multiply give me negative 96 and add negative 4? We're looking at negative 12 and positive 8. X minus 12, x plus 8. And if I solve this, x equals 12, x equals negative 8. Now, a question for you. If I'm plugging things in for a distance around a ceiling and like a wall or anything like that, do you want a positive number or a negative number? I want the positive number. Negative number doesn't make any sense. So if I plug 12 in over here, check this out. My length is x plus 7. 12 plus 7 is 19 feet. This is just 12 feet. And this is 12 minus 2, which is 10 feet. Alright, now, the last part I'm going to let you guys play around with a little bit. It says, for supplies, the painter knows that he must purchase primer, which is 21.98 per gallon and covers 200 square feet of wall. And paint is blah, blah, blah. If he wishes to prime and paint all 4 walls in the ceiling, how much will the supplies cost the painter? Alright, your next job is to figure out what the area is for the entire thing, including the ceiling, and determine how much paint and primer he needs for it. Okay? Again, we'll talk about this a little bit in class, but for the most part, from there it's all downhill. It's just kind of plugging numbers away and going from there. Difficult problem, very, very good problem. It's actually a real world problem too. I've done something similar to this with laying flooring down in my basement. I had to calculate the area, figure out how much the supplies cost, everything else. Very, very nice problem. A little bit easier because I wasn't dealing with expressions, but you get the idea. So that about wraps it up, guys. This is basically your test. Like I said, we'll start this on Thursday. We'll finish up on Friday. Keep up the good work as always, and good luck. We're all counting on you.